Have you ever gone to open a door and received a painful shock from the metal doorknob? Maybe as a kid in school, you rubbed a balloon on your hair to make your hair stand up. These are both examples of static electricity in action. Today, we're going to talk about what static electricity is and where it comes from. Let's get started. Let's start by looking at what causes static electricity. Static electricity is caused by the tiny charged particles, called electrons and protons, that make up matter. These particles can be positively charged or negatively charged. Due to the electric force, protons and electrons are attracted to each other and will move toward each other if possible. On the other hand, electrons are repelled by other electrons, just as protons are repelled by other protons, and they'll move away from each other if possible. This attraction and repulsion can cause a large amount of charge to move from one material to another. The effects of static electricity occur when there is an imbalance of protons and electrons on a material. When there are an equal number of protons or electrons on an object, the object will be neutrally charged, but with excess electrons or protons, the object or surface will have a net positive or negative charge and exhibit static electricity. A great example of this is the balloon scenario I mentioned earlier. When a rubber balloon is rubbed on certain materials, like hair, it will pick up extra electrons. This makes the whole balloon negatively charged, since there are more electrons than protons on the balloon. The negative charge of the balloon will be attracted to materials or surfaces that have a net positive charge, or a neutral object whose electrons may move away. This is why you might see a balloon looking like it is stuck to a wall or some other object. Sometimes, if the loose electrons are unable to move to another charged object, they will gather at the end of the object that is near something with opposite charge. When this occurs, the object is said to be polarized, meaning that one end of the object is negatively charged and the other end is positively charged. This is similar to the polarized ends of a magnet. In most cases, static electricity is simply caused by two objects coming in contact with each other. Some types of materials have atoms with outer electron shells that are missing electrons, while others have loosely bound electrons on the surface. When these two types of materials come in contact with each other, they are easily charged. This is referred to as the triboelectric effect. More rarely, some materials may become charged with high heat or pressure. So, what causes the shock associated with static electricity? If there is a big enough imbalance in charges on an object, a static discharge may occur by some of the charge flowing to nearby surroundings suddenly. If the charge flows through particles in the air, it may cause a visible spark or even a painful shock. One very dramatic case of electrostatic discharge is lightning, where electric charges flow in clouds or from clouds to the ground. The effects of electrostatic discharge can be dangerous. Sparks or shocks to electronic devices may cause damage to the device, but they may also be harmful to us. If it is a small shock, it is not likely to cause us any real pain or damage, and may even be a fun experiment if it is in a well-controlled environment. On the other hand, if an electrostatic spark occurs near flammable or combustible substances like gas, it could possibly cause a fire. What can you do to reduce the risks? Luckily, it is quite easy to safely discharge static electricity by touching a conductive object, like metal or the ground. This allows the excess charge to flow away without causing a spark or sudden shock. This discharging is referred to as grounding. Now that we've learned all about how static electricity works, let's go over a couple of quick review questions. Number 1. If two balloons, each carrying a net negative static charge, are brought near each other, what will happen? A. They will be attracted to each other and stick together. B. Nothing will happen. They will not react to each other. C. They will explode. Or D. They will repel each other and move apart. The correct answer is D. Negative charges will repel other negative charges. This will force the balloons to move apart. Number 2. You have acquired a static charge on your body, but need to fill your gas tank. Which of the following would prevent causing a spark that could ignite the gas? A. Touching something metal. B. Rubbing your feet on some carpet. C. Rubbing your hair and sweater with a balloon. Or D, talking on your phone? The correct answer is A. You'll need to ground yourself and discharge the static charge to prevent a spark. That's all for this review. Thank you for watching and happy studying.